Now let's see how we solve problem S3 in C++. And these are the header files, declaration for the namespace std, and then some global variables and m for the size of the grid, and then a pointer to the grid. Keep in mind this is a two-dimension array, so it's a pointer to pointer. Here we have a map to track the empty cells, and as we said in part 1, we use a tree and start from the initial position of the robot. So we need to track where the empty cells are, and then we need to track if a cell is already in the tree or not. So we have a set to track all the accessed cells. And then we have a function camera path to say if a camera can see through this cell or not. And then we have a function is on the camera to check whether this cell can be seen by a camera. And we have the location of this cell in the grid. So we check whether if the current cell is a C, which means it's a camera, then it is on the camera. If it's an empty cell or it's the start cell, then we need to check further to see if on the line there is a camera. So here we are going up to find the camera, and then we are going down to find the camera, then we're going to the left to find the camera, and then we are going to the right to find the camera. And if there is a camera in any direction, that means this cell is controlled by a camera. That means the robot can't go through this camera. That means the robot can't go through this cell. And then we have utility function accessed, just to check whether the cell on this location is already in the tree or not. And then we have the check cell. This is a function that goes through the nodes at one level in the tree. And we have the input, that's the current level of the tree. And then we have the output, that's the nodes at the next level of the tree. And we have the steps, that's basically the level of the nodes in the tree. And there is also how many steps does it need for the robot to get here. And now we have one vector for the same level. This is basically for conveyors. As when conveyors move, the steps does not increase, and that means all the nodes along the way, they're all at the same level in the tree. So if the input is not empty, which means there are nodes that we need to check, and then we go through the nodes. And if this cell is already accessed, it's already in the tree, then we skip this cell, we check the next one. If it's not, we put it into the set, and then we get the position for the current cell. We check the character in this location. If it's an empty cell, then we check whether it's on the camera or not. If not, then we know we can get here, and then we put the steps in the track of the empty cell. If it's not already set, sometimes there are more than one ways to get to an empty cell, but as we are using the tree, so only the first time you get to this cell, that's the minimum steps needed to get here from the initial position. And this is only for debugging. When I was debugging the code, I want to print out the information, the location of the cell and the steps of the cell. You can also enable it if you want. Then we check the subtrees for this cell, as we can still go further. We check the up cell, down cell, left cell, right cell, If there is one, which means if we are not at the boundary, then we put it into the output for the next level of nodes. And then if it's an error, that means it's a conveyor to the left, then we just move the location to the left until we can move. Then we put the cell where the robot stops to the same level, as this cell is at the same level of the tree, so we need to process it this time because the steps does not change. And same for R and up and down. And then if it's the initial step, the starting point, then we need to it's similar as an empty cell, but for starting point we do not check the steps of it. We just put the up, down, left, right cells to the output for the next level of nodes to be processed. And if it's a camera or it's a wall, then there's nothing we need to do. It's just the end of the tree. And then after this, as for conveyors, we have some cells to be processed here in this function at this level. So we swap the input in the same level, and then we clear the same level, and then we go back to this loop and process those cells again. And this is this function, and then get steps, and we have the starting point and steps. This should be 0 here. As from the starting point, there is no steps taken yet. And then we have the input output. We put the starting point to the output as the first level of the tree to be processed, and this is the root of the tree. And then we have where output says is bigger than 0. This means we have subtrees, we can move further, and then we swap input and output, and then we call the check cell function to check the nodes at the level of the tree. And of course, in each time the steps is increased by 1. And then in the main function, so we have the input processing to read in the size of the grid and also the contents in the grid. And here for the contents in the grid, we need to track the start cell, so we know where we start, and we need to track the empty cells, so we know when we print out, we know what empty cells we have in the grid, so that we don't have to go through it again. And then we calculate the steps. Sometimes the start point can be under a camera, so we need to check whether the start point is on the camera or not. And if it's not, then we call cat steps. If it is, then it cannot move from the start, so it can't reach anywhere. And then the output, we go through the empty cells, we print out the steps for each cell. In C++, this map is ordered, so you don't have to worry about the order in the map. The keys are the locations of the row and column, and the order of the map is based on the key. So it's ordered well, there is nothing to worry about. And this is only for debugging. And this is the end of the program. And now let's test the program. Now we are ready to test the program against the sample 1. I've already copied the sample input, so here I put the input here, and we got the output as -1, 2, and 1, which is exactly same as in the output from the sample. So the program works for sample 1, and now let's test the sample 2. Now we are ready to test the sample 2, so just paste the input here and then press enter, and we got the output. 2 and 3 minus 1 minus 1 1, which is also exactly same as in the output in the sample. So our program works for sample 2 also, which means that this code is the right solution to problem S3. Okay, okay, I hope you guys enjoy the video. If you like it, please thumb up, and also please subscribe to my channel. I have videos for more problems. You don't want to miss them.